Please check your homework. Okay. Yani I am waiting to do now two homework. First one is the MATLAB application. Second one is the forklift dynamic equation. We will do it. Did you send me, Hamza? You sent me only first one. No, still. Okay, I am waiting. Okay. Thank you. It's very important because your midterm project is combination of your homework. Okay. Thank you. Today, we're gonna continue with the DC motor. Actually, in midterm project will be DC motor control. In final project, BLDC motor control. However, don't forget that we will organize power system requirement, DC motor, power electronics control and discussion, and it will be our content. Okay. Now, in this week, I am waiting from you. You must finish vehicle dynamic, and then now we start the DC motor control. DC motor, you know the very basic motor types. Actually, it is efficiency is very low, etc. However, in the automotive environment, automotive application, brush direct current, yani DC motor is meaning that brush direct current. Okay, Uh, especially automotive application, home appliance, etc. We are using DC motors. It play an important role in the control of this application area because mirror folding control, for example, in your vehicle. Okay, window lifter, ondan sonra drill machine, etc. Seat control, sunroof control, because uh, DC motor is very cheap. However, brushless DC motor, etc., and permanent magnet motors are very expensive to the DC motor. Main philosophy of the motor control, electric drive principle, depend on the DC motor. If you understand very well DC motor control techniques, probably you will be expert or you will be professional in the other motors control area. So today's course is important for the understanding of the philosophy. Okay. Now in automotive, you can see the automotive just an example for lighting, boost recovery. This power recovery is a power electronic. It's converter power electronic, climate control mechanical. However, window seat sunroof control, and also yes, these are depend on the in the automotive application based on the DC motor and its drive system. It's just an example. Okay, don't forget it. Yani electric vehicle, another area, wind turbine, another area for drive system, automotive application, especially white good application, home appliance application. Uh, Another example, as we talked last week. Today, main learning outcome will be H-bridge application of DC motor. H-bridge means that four quadrant operation of the DC motor. Okay, we will discuss it. Also, we will learn it. Normally, for example, 5 years ago, no, 5 years ago, 10 years, 20 years ago, in DC motor control, in automotive application, they are using relay. Okay, generally, they are using a relay. Now, relay and MOSFET, because you can estimate it. Relay is very cheap. They don't need any microcontroller. They don't need any peripheral IC components, etc. If you want to drive a DC motor, you need a microcontroller, ICs, etc. So it will be expensive. But the last 20 years, 10 years, IC prices is reducing classically because electronic age uh, where is growing. Normally, relay in the classical automotive application, yani it means that the average of the last 80s, 90s, actually 2000s, 2010s, um, 30 relays are used in a car. For example, in the mirror, the in the raining time, actually you hear Relay noise. Tick, 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 tick. It means that it's relay. Third relays. It's very high, and don't forget it, relay is just an electromechanical components. Yani normally MOSFETs and IGBT etc. it's a semiconductor. If you use a semiconductor, this is called as a electronic. It needs electronic board. It needs software etc. But it's very reliable. Driving a relay is very simple in automotive application. The internal resistance of the connection can be very low. Also, however, compared with the relays, MOSFETs have some advantages in noise, service life, miniaturization, reliability. Okay, for example, if you use a MOSFET, you cannot hear any noise. Also, service life is very high. Why? Because relay is electromechanical, MOSFET is chemical, physical material. It consists of chemical material. Also, best benefit, most important benefit of the semiconductor relay generally very high volume. Okay, MOSFET is very low volume. Another example. So at the lastly, we can say more and more manufacturers consider using MOSFETs to replace relay. For example, last week, an automotive company, I contact with them, their card using a relay. For example, I will show you a classical sorry. I will give you some example. For example, they are using a relay. One relay is used for forward direction control, another one reverse direction control. For example, lifting of the vehicle in the bus, for example, on the DC motor. One relay permits is a permission for direction current flowing. Another one, reverse current flowing. Okay, this is very classical application. However, now we must learn and we must apply semiconductor. For example, here they are using MOSFET, also relay. One MOSFET plus one relay. This is they it per yes, one MOSFET, one relay, fourth quadrant. Yani you can apply forward direction, you can apply reverse direction. Also, you can regulate the speed using a MOSFET. How we can regulate the speed? Don't forget it. Semiconductor generally has a gate input. If you have pulse width modulated square wave signal, you can apply it to the gate of the MOSFET. You can create an voltage value, but what not constant voltage value. It depends on your duty cycle. For example, if your duty cycle is 50 percentage, this means that your average voltage value for a DC motor, for example, 24 times 0.5, it means that 12 volt. 12 volt, it means that half speed. It's the half of the rated speed. Okay, this is not modern. Actually, our main focus point in this course bidirectional MOSFET-driven DC motor. Here we have four semiconductors. We can use this topology for forward, reverse. So don't forget it. Another point in the motor control application, we are using clockwise and counterclockwise. Forward is meaning that clockwise, reverse is meaning that counterclockwise. At the same time, motors are working as a motor and generator. If you use the H-bridge topology, you can generate a power. It means that your your machine works as a motor. Also, if you generate an energy, it means that your machine works as a regenerative braking. So, first one, we can summarize again. You will see in automotive factory three applications. One of them only relay. Second one relay plus one MOSFET. Third one, all of them will be MOSFET. It means that H bridge. So, for example, a company product, they are using relay. This is the relay replacement demo actually. Lots of company try to convert it only MOSFET. You will see 4 MOSFET here, 4 MOSFET, 2 MOSFET here, 4 MOSFET here. Different application area. Probably using a Discord, they are using single one MOSFET with relay for H bridge. Only relay. It's just an evolution board. Typical application, folding machine. Okay, now after this one is important. Brush DC motor. Okay, the DC motor is common actuator, common actuator in the automotive environment. And in order to understand how to better choose the controlling, its their rating, also as well as obtain the behavior selection, etc. Now, in this figure, you can see electric circuit of the DC motor armature. Okay, this is called as a DC motor armature. Here, this one is the armature resistance. This one is the armature inductance. This is E is called as a back EMF. Armature current is meaning that current flow. Also voltage is supply voltage. Moreover, we can say G. G is the rotor inertia. Theta, also we have a theta here, you can see. Theta is rotor angle. T is motor torque. Okay. Now we understand the parameter RA, resistance of the armature, LA, inductance of armature, E, back EMF of motor, G, inertia, V, supplied voltage, I, current value, T, torque, also theta, rotor angle. Now, in first equation, V is the input voltage to the DC motor and the one supplied by the H bridge. Okay, what's the H bridge? You remember, which is formed by 4 MOSFET within 2 half bridge. Okay, actually this one. Wait me. Yes, half bridge is mean that this one is one half bridge, second one, second half bridge. Totally we can call it H bridge. Okay, 2 half bridge are combined. It means that H bridge. Also, considering the magnetic field, if we say electric machine, magnetic field is very important for us. If you consider the magnetic field as a constant, the torque produced by the DC motor will thus the proportional value of the armature current. Every motor have KT value and KE value. KT value is mean that torque constant. Okay. KE is meaning that back EMF constant. So we can say armature current I and torque value are proportional. If you want to control, if you want to increase torque value, if you want to decrease torque value, you need to regulate your current value. It's very important because we will use we will use it uh, we will use it in the next controller applications. So another one, E. E is mean that back EMF. How can we obtain back EMF? Ke times d theta over dt. What does it mean? Ke is back EMF constant, dt over d theta over dt derivative term of the rotor position. It means that E equal, and actually you know the derivative of rotor position is mean that speed. Speed is angular velocity, omega. Omega is angular velocity. Omega times Ke, it means that E. Yani we can say rotor back EMF value, so voltage value, is proportional with the speed. So actually we can say torque is nearly same, nearly proportional of current. A voltage is nearly proportional with the speed. So every motor catalog present us torque constant value. If you want to model, for example, last week some of you try to model DC motor, benefit from the uh, Michigan University MATLAB website. You remember you have a KT value, you have a KE value. It will be a recognized factor of your motor maximum speed value and maximum moment value. Generally, lots of company present us their torque constant and their back EMF constant. Okay, so another point in DC motor, generally in DC motor, not BLDC, not PMSM, in DC motor we can accept KT and KE are same. Generally, back EMF constant and torque are equal. Okay, if we accept they are same, we can say KT equal KE. We can generate mechanical domain and electrical domain. Now, if you see, G depend on the torque value, and D, what is D? D is the viscous friction. Okay. If you want to model your mechanical, maybe you can remember 1 over Gs plus B. You modeled last week. This is your mechanical plan of the mechanical system of your DC motor. Same thing are Ls plus R. This is your electrical Laplace transform of the electrical side of your DC motor. Okay. If you want to model, probably you can remember this is your block. Input is voltage, and then you have K E plus plus this load torque load. Also you have probably KT, and then arrow, and it will be your output. Lots of the class build it. Now, H-bridge theory. What is the H-bridge theory? Okay, we define the DC motor parameter. We define the effect of the DC motor parameters. Now we can start H-bridge theory. The H-bridge also known as a full bridge actually, because I said you combination of two half bridge. It means that full bridge is an electronic system. Okay, consisting of the four switch and capable of the creating a bidirectional current and reversible voltage across its load. This function comes in handy when driving a motor because it allows a change in the direction. This approach permits us as a permission for us direction changing. Okay, if you want to change your motor in your application, you should apply H-bridge topology. If you use a one MOSFET, your motor goes only one direction. Okay, if you want to speed control, if you want the direction control, you must use H-bridge for DC motor. Okay, so this circuit, H-bridge circuit, actually it's not used in only DC motor. We are using it inverter, we are using it regulator, and DC-DC converter, DC-AC inverter system, and some amplifier. It's very generic power electronic circuit. The edge bridge can be thought of as composed of two half bridges used simultaneously. Okay, the edge bridge allows us the motor to work as a generator in both direction of rotation. Therefore, it's considered four-quadrant converter. The half bridge is capable of bidirectional current but not reversible voltage and thus is considered two-quadrant one. For example, if you use only one side, yani half bridge, if you use half bridge converter, you can your motor will goes only two direction. However, it work as a only motor. If you use four quadrant for two half bridge converter, you can apply forward motor application. You can use reverse brake application. Don't forget it. Motor operation and brake operation are different. You know, in electric vehicle especially, the main important point of the EV, regenerative braking, and at the braking moment, you can generate a power. Your battery level is increasing. This is called as a regenerative braking, and it means energy recovery. Okay. Also, this is four quadrant. In four quadrant, I times yani current times voltage will be positive. Okay. Reverse brake, positive is mean that motor. Current times voltage is minus value here, plus time minus, it means that brake on the different direction. Also here current minus, voltage minus time minus will be plus, so it means that's motor but reverse. Here current minus, E plus, minus times plus, minus, it means that brake. Okay. And philosophy of four quadrant, we can operate four quadrant in a coordinate plane. Every quadrant has a special function. One of them forward direction and motor working. Another one reverse direction, braking working. Next one reverse direction, motor working. Last one forward direction, brake working. Okay. Therefore, yeah, for example, some companies want from you only one, yeah, single direction application. For example, you are working in a factory. They want from you oil pump motors. Okay. For example, oil pump motors and small fans work only one direction, single direction. Okay. If companies from you single direction, you can use only one MOSFET, for example. Yani you can imagine you have a ventilator in your home. You need to regulate your speed, a function. Your ventilator works only single direction with a different speed level. You can use only one MOSFET. Okay, it will be work as a motor. You need to regulate your speed. If you don't want to regulate the speed, for example, you will apply 12 volt your DC motor. It works a full operation and only single one speed level in only one direction. You can use a relay on position. Okay, on position motor works at the rated speed. If you want to regulate speed, you will apply a MOSFET, one MOSFET. If you want to regulate direction, you must apply two MOSFET. If you want to regulate direction and the motor and regenerative braking operation, you must use four MOSFET. This means that edge-bridge operation. Okay. Now, switching function is important. You see here we have a PWM, 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 PWM. You develop a model in the midterm project. Okay. You will apply and pass with modulation. Now, this is called as a bipolar drive system. This is called as a bipolar drive. What's the bipolar drive? Bipolar drive allows the MOSFETs to be switched on at a time. For example, we can erase this page. Wait me. Sorry. How can we erase it? Yes. No, this one. Huh. Okay. We can draw the current way together for bipolar DC motor. Okay. You can see right side of your screen. This means that positive current from node A here, to node B, both Q2 and Q3 are turned on. Okay, Q2, Q2 here, Q3 here. This way is a direction. Which MOSFETs are on position? Q2 and Q3. Q1 and Q4 off position. Whereas for negative current, don't forget in DC motor application we have one positive, one negative current, because you know we have a two cable, one of them positive, one of them negative. For negative current, Q1 and Q4 are turn on. Okay, this is negative current. By switching these two pairs, the direction of the current can be controlled, thus applying a voltage across the motor that varies between the DC link voltage and minus DC link voltage. Okay, for example, you have a battery 24 plus 24 minus 24. This is your called as a DC bus or DC link. In a vehicle, a battery, for example, 12 volt. In your home, not a grid voltage. You know it is AC. If you use any converter, you can convert it to DC level. After that, you can apply the edge bridge motor DC motor control. This is for only DC. Okay, average value of your DC voltage is depend on your duty cycle. What is it? Duty cycle is here. Okay, you can see. Now, green one on. This is your, you can remember from power electronics, on. Here, here off. Electronics on. Here, here off. Duty cycle, here 50 percentage ratio. It means that your voltage value will be equal if you have, for example, 24 volts. If you apply 50 percentage duty cycle, it means that 12 in your screen. And actually you can create a square wave signal to gate of the MOSFET, and then you will regulate speed of your motor. Another important point, every time Q1 and Q3 will be complementary, okay? Because this is called as a shoot-through, because it will be short circuit if they operate at the same time, okay? It is very bad condition, very bad situation. It is called as a shoot-through. These are worked as a complementary. If it is on, it is off. If it is on, it is off. Okay, this is complementary operation. Also another point, dead time. Why is the dead time? Dead time is mean that we want to prevent overshoot. Shoot through, sorry. Shoot through. Yani it is on, it is off. Another cycle, it is off, it is on. Nasıl? This is on and then this is off. However, However, for example, another switch on or off. If they operate at the same time, like this one, yani one of them falling, another one rising. Okay, we want to prevent it. We can apply it that time, like this one. You can see here, falling. You see, rising time. We can add at that time. For example, at 10 kilohertz switching frequency, it means that minimum 3.6 microsecond. Okay, it means that a delay, for example. It's very important. In your simulation study, in your simulation study, switching components are ideal, so we cannot add any that time. In the real application, if you use a real MOSFET, you must add that time. Okay. For this operation, if for phase Q2, Q3 on position, Q2 and Q3 on position, Q1 and Q4 will be off. What's the output? VDC. Okay. If you have a B for B phase, yani it means that one direction A, one direction B. In B direction, Q1 and Q4 on, Q2, Q3 off. At this situation, we have minus DC link voltage. Okay. So another one, driving cycle. You want to build a motor control. And generally, if you want to drive expert, we can start DC motor controller. For example, you can buy from the market an IC. Okay, you can buy a DC motor. You can build in your home using an Arduino a DC motor controller H bridge. I recommend you actually. Yani it's not a necessary, but it is very beneficial for you. I recommend you. In the classical DC motor drive system, we have power supply. What does it mean? Power supply sometimes it means that a battery sometimes is a power supplier. Okay. In your home, sometimes a AC grid, you will add a converter to convert to DC. It means that power supply. For example, you can buy from the market 9-volt alkaline battery and clock. What's the clock? Generally, we can generate the clock. Clock is mean that if you're interested with the Arduino, etc., timer. Why we are using a timer? Because we need to regulate PWM period. Period is now we need to switching frequency. It means that period. If you want to create a timer, you can measure current value. Also, you can generate a square wave. Okay, clock role is available in the microcontroller. Generally, clock and PWM side of these circuits, for example, Arduino. If you use any Arduino, any microcontroller, you can build your own circuit. It means that clock, after clock generation, you can apply a PWM. How much seconds on time, how much seconds off time, okay? And then driving circuit. Driving circuit is, you can remember 2 page ago, FH H bridge circuit, H bridge circuit here, sorry, all MOSFETs, you can remember, yes, here, all MOSFETs needs a gate driver. If you have a MOSFET, you must use MOSFET driver. In this circuit schema, you are seeing only MOSFET. However, we have a circuit here, MOSFET driver. Yani you can take from the market MOSFET, and MOSFET driver. Okay, if you want to drive a MOSFET or IGBT, you must use driver. So, and then motor. Also, this is current detection. How can we detect the current in DC motor application? We must use a current sensor. How many types current sensor are available? For example, one of them, Hall effect based current sensor. If you have a hole in your sensor, you can use the hole of the sensor. Your cable goes in this hole. This is Hall effect current sensor. Another one, PCB type current sensor. Cheapest one, is shunt sensor. You can use a resistor for current measurement. It's very cheap. For example, home appliance and white good application, we can use shunt resistance for measurement, for measure the current. Overcurrent detection is mean that if your current value increased or has a peak at the instantaneous, your circuit will generate a signal. Your microcontroller generate a signal. What does it mean? I measure peak current value. For example, your maximum current value is 10. At a one moment, your current sensor measure 20 ampere. Your microcontroller generates a trip signal. Your MOSFET will be disabled. Okay, this means that overcurrent detection. Actually, this is the closed loop system. If we have a sensor, if we have a loop, closed loop sensor, this is called as a closed loop sensor. Also, if you use any speed sensor, for example, encoder measure the rotor angle. This means that you can measure your speed, your position of motor, measure your speed of motor. For example, you have a reference speed in white goods, for example, your reference speed value 100 RPM revolution per minute. Okay, if you want to take a 100 RPM, you must follow feedback speed. This is called as a closed loop system. Good. This is typical average power value of DC motor. Why this graph is important for us? Because in DC motor, don't forget it. Engineering, it doesn't mean that only appliance, etc. Measurement technique, another side of engineering. If you build a circuit, if you build a drive system, you can measure your feedback values. We cannot use anytime multimeter. Generally, in laboratory we have an oscilloscope. We are using an oscilloscope for voltage measurement, current measurement, etc. Because in your home, RMS measurement is a way, but in the motor we have this type of current value. In the reality, our voltage value like this one. You can see pulse off, pulse off, pulse off. If you use a multimeter, you can measure RMS value of this signal. It is very bad solution. Okay, this is just a technician approach. You must use oscilloscope. Okay, actually your current value like this one, triangle. Why like this one? You can remember from power electronic course. It's inductance effect. Our motor has a winding. Okay, this is inductor behavior. Current increasing, decreasing, increasing, decreasing. So we can say motor parameters are very important for control. Some motor types are very capable for regenerative braking because they have high energy storage capability. Their inductance is very high, they store energy. Some motors inductor value is very small, they cannot store any energy. If you want to special motor type for some application, you must check parameters of motor. Okay, for example, moment of inertia. If your moment of inertia is very high, your starting current value of your motor drive system will be very high. For example, your rated current value is 5 ampere, and starting time you will measure 30 ampere, 40 ampere, for example, if you have high moment of inertia. Okay, so we are using oscilloscope in our drive application. This is typical power value. Uh, Firstly, this is the starting value. For example, nominal power, it generates nominal power nearly 5 watt, for example. Okay, 5 watt. At the starting of motor, it increases to 40 watt, 8 times. Okay, in the starting times, high current region. After that, this is called as a transient. This is called as a steady state. We have a so error in this region. Here, after that, we have only steady state errors. Also, the signal is DC, don't forget it. And this is a DC motor. In AC motor, this graph will be changed. Okay, DC motor is mean that voltage times I, power generation. Voltage DC, current DC. DC times DC, it will be DC, you know. Okay. Another side, typical DC motor, very small. Actually, there are very big DC motor. For example, some train application, their volume is very high, like your home. For example, some fabric use a generator. For example, in some wind turbine, we have very big DC motor, but it's just a small example. This is called as a flywheel. Okay, if you want to develop the regenerative braking algorithm, you will design a flywheel. This is called as a flywheel. Okay, your motor, for example, you can imagine we are going at the 1000 rpm revolution per minute, and then you cut off your all MOSFETs, non-energizing. However, this flywheel try to continue to its rotating. This means that this rotating element generate a power to my motor. Okay, this is regenerative braking application. So moment of inertia G depend on your 1 over 2 m square of r. R is radius. Yani your motor length and your motor width is important for moment of inertia. Another one, winding resistance. Winding resistance calculating steady state voltage value and steady state current value. If you want to calculate your winding resistance of DC motor, why we can calculate the resistance? Because main voltage equal R times I plus L di dt plus E. L times di dt is negligible for steady state operation. We can assume it's zero. Actually, my voltage value will be equal R times E plus R times I plus E. Okay, back EMF and R times E. So we can say I have some restriction components. One of them R. So every time in simulation, in real time application, we need to measure my R value. So if you operate at the steady state condition, steady state, you know, it's mean that this is steady state. These are transient, instantaneous, starting moment. These are steady state. On the steady state time, you can measure using a multimeter or current sensor or voltage sensor, etc. Apply step voltage 3.675 volt. You measure a current at steady state 2.39. If you want to measure your R value, V over I with classical Kirchhoff law, 1 over 54 ohm, my motor resistance value. Also, this is the oscilloscope waveform, DC motor operation. It is your voltage value, voltage. Okay, this is the chopping time. We can measure in the multimeter average value of this green waveform. Normally, if you measure with the oscilloscope, you will see like this one. My current value, back low, and then if you apply a voltage, it will be increase. If you stop the duty cycle, this moment current start to reduce, increasing, reduce. Your current waveform like this one. Okay. Increasing moment, voltage apply, decrease moment, non-voltage apply. I recommend you actually in midterm project. I recommend you actually in midterm project. I will give you a midterm project. You have a 4 week. You have a 3 weeks. You will build an H-bridge DC motor control circuit. In the MATLAB library help section, you will see it. But I want from you, you will use your dynamic equation. In the last week, I gave you a homework. You will generate a power, torque, and speed. You will use these values, and then you will build an H-bridge DC motor controller circuit, and we will see results of your project. I will upload detail of midterm project. You can follow it. You have a 2 or 3 weeks. I don't know. Today I will decide it. Okay. Today is enough, I think. Also, next week please come at the 3 o'clock. Okay. Onun dışında. Okay. Thank you for your attendance. We can finish. Online courses will be 1 hour. Do you have a question to me? If you have a question, you can visit me in office. Okay. Generally 4 days of a week I am here. Okay. See you.
I just have a question about homeworks.
Yes.
Is all information about homeworks in the files you submitted in OLERN?
Me?
Yeah.
Yes. I submitted OLERN. You can check OLERN.
Yeah, all the information are in the files, right?
Yes.
About
To do now, yes. On midterm project, I will upload.
Okay.
First 2 homework, I upload it. You can check OLERN. For midterm project, I will upload this week, probably.
Thank you.
To do now, yes. You can check. Okay.
Thank you.
Thank you. See you. Goodbye, everybody.